Okay, so for this section, we're going to look at section 1.7, but we're going to talk about linear inequalities for this one. Okay, so for linear inequalities, they are solved the exact same way that you would solve a linear equation, meaning you can add to both sides, subtract from both sides, multiply both sides, divide to both sides to try and get x or the variable isolated. The one key exception is that if you multiply or divide by a negative number, you have to take that inequality symbol, the less than symbol, the greater than symbol, whatever it is, and you have to flip it the other direction. Okay, so the first example that we're going to look at, okay, so the first example that we're going to look at is going to be 2 minus 3x is less than or equal to 5. Okay, so 2 minus 3x is less than or equal to 5. Now, so the first thing we're going to do is now with this, there are some students who they see this -3 here, and some students they have to have letters on the left. That's where they're traditionally used to seeing them, so they end up with something like x is less than or equal to, greater than or equal to, something like that. If that is your scenario, then you will have to worry about dividing by this -3. Other students don't want to have to remember that rule. Okay, so they opt to just move the letters to where they're going to be positive. Now, I'm going to do it with the traditional letters on the left, just to make sure that I can show you what that rule is going to do. So I'm going to subtract 2 from both sides. So it's going to be -3x is less than or equal to 3. Then I'm going to divide by -3 on both sides. And before I do anything else, I'm going to go ahead and take that symbol and switch it to the other direction. That's now going to give me an x. 3 divided by -3 is going to be -1. So I've got x is greater than or equal to -1. If I need to put this onto a number line, here's -1. I'm going to have a bracket on it, and I'm going to color up this direction. This is already very, very similar to set builder notation. And if I needed to put this into an interval, I could run it out to here. Okay, now we do sometimes have some intervals, or when we work with these, we will have some that do kind of some strange, we have kind of some strange answer sets, and I'm going to show you what these look like as well. So we do have some that we're not going to have a solution at all. So it's going to use that same circle with the slash through it to indicate that there is no solution. However, on some of them, we will also get that any number will work. And for that case, we'll either be using the negative infinity to infinity or all real numbers type of notation. So we're going to take a look at an example of kind of what one of these looks like, okay, as we process. So the example that we're going to look at is 3x plus 1 in a set of parentheses is greater than 3x plus 2. Okay. So first thing that we're going to do is we're going to distribute here on this side. So now I have 3x plus 3 is greater than 3x plus 2. Now I'm going to work to get all of my x's on one side. So I'm going to go ahead and take these and I'm going to move them this way towards the left. So I'm going to subtract 3x from this side. So I'm also going to subtract 3x on this side. Now, that's going to leave me 3 is greater than 2. Now, since all of my variables canceled out, that is what indicates to me that I'm either going to be in a no solution or an all real number setup. Now, the way I decide this is by whether or not this is a true statement. If this is a true statement, in this case it is 3 is greater than 2, then that means that this is all real numbers. And so it's going to be an interval that looks like that, or you may see them also do something like that where they talk about all real numbers. Now, if you had worked a problem, so let's say we had this exact same setup, but that inequality symbol had been the other direction, okay? Again, distributing. Again, this is all going to be the exact same set of math that we were doing. Subtract my 3x, subtract my 3x. I've got 3 is less than 2. But 3 isn't less than 2. So this is a false statement. So that's what indicates that that is going to be a no solution for that setup. Okay. So hopefully this kind of helps you get through how to solve linear inequalities.